All right, let's just jump right in. If you're out there building an AI agent for any kind of business, I'm going to bet there's a pretty good chance you're building it on a foundation that's, well, it's flawed. And it's a flaw that's costing you a ton of money and making your product super unreliable. But hey, that's what we're here to fix today. We're going to explore a much smarter, way more robust way to build things, the hybrid agent architecture.
So let's kick things off with a pretty shocking number. What if I told you that right now you're probably spending 10, maybe even 50 times more on tokens than you actually need to? It's wild, right? The problem is most of the tutorials out there guide you down a path that looks amazing in a demo, but it's an absolute recipe for disaster when you try to build a real-world, scalable product on top of it.
And this quote, this just perfectly nails the issue. Hiring a brain surgeon to sort your mail. It's brilliant. We're using these incredibly powerful, incredibly expensive models for the simplest, most basic routing tasks. And it's not just about the cost. It's slow. And, maybe most importantly for any business app, it's non-deterministic. You're basically paying top dollar for an unpredictable result, and you know what? That is a losing game in a production environment. So, where is all this massive cost coming from? Well, it's what I like to call the hidden token tax. It's a tax you pay when you build what we call pure AI agents. It's this deep inefficiency that's baked right into the standard architecture that, let's be honest, most of us were taught to use from the start.
And that standard architecture is the agentic loop. You've definitely seen this in tutorials for frameworks like LangChain or Crew AI. You know the drill. The LLM is the big brain in the middle. It thinks, it decides to use a tool, it gets a result, and then it has to think all over again, looping and looping until the job's done. Now, on the surface, that sounds super intelligent, right? Autonomous even. But underneath, it is hiding a massive compounding cost.
Let's make this real. Imagine a simple invoice processing task. So, step 1. The LLM reads its instructions and decides, okay, I'll read the PDF. Cool. Step 2. The entire text of that PDF now gets stuffed into its context. Then, for step 3, it thinks again and decides, I should check the database. And what happens in step 4? That database result also gets added to the growing context. You see the pattern here? With every single spin of the loop, the context window, the history of the model has to reread from scratch every time, just gets bigger and way more expensive.
And here it is. This is the crucial point, the real aha moment. LLMs are stateless. What does that mean? They have no memory. None. So every single time that loop runs, you have to send the entire conversation history back to the model. Think about how wasteful that is. By the end of the process, you are paying to reprocess the initial prompt, all your tool definitions, all the previous results, just so the LLM can make one more often very simple decision.
And this chart, wow, it just brutally lays out the cost. A standard agent loop can eat up 5 to 15 times more tokens than just calling the API directly with the information it needs. And if you're using one of those complex multi-agent setups, forget about it. That can explode to 30, even 50 times the cost. This right here is how your profit margins just evaporate.
So how do we fix this mess? The answer is a fundamental shift in architecture. We have to take the job of orchestration, the looping and the routing, away from the expensive LLM and put it back where it belongs, in simple, fast, deterministic code. And this approach is called the hybrid agent architecture.
Just look at this comparison. It makes it so clear. On the left, with the pure agent, the LLM is the boss. It's the orchestrator making every single decision. But on the right, in the hybrid model, your code, your simple Python script, is the orchestrator. The code runs the loop and it calls the LLM like it would call any other function, but only when it needs a specific high-level cognitive task done, like making sense of messy, unstructured text. The LLM becomes a specialized tool, not the general manager.
And making this shift really just comes down to a playbook of 3 core principles. It's actually pretty straightforward. First, you're going to use code for routing, not the LLM. Second, you'll use a real database or a state machine to manage state, not the LLM's chat history. And third, you prefetch data instead of giving the agent tools and hoping it figures out what to do.
Let's break that first one down. You need to stop asking the LLM open-ended questions like, what should we do next? Instead, you force the LLM to give you structured output, like a JSON blob or a Pydantic object. Then, back in your code, you can use a dead simple, rock-solid if-else statement to decide the next step. I mean, think about it. Your code runs in a millisecond for free, while the LLM takes seconds and costs you real money for every single one of those decisions. It's a no-brainer.
Next up, you have got to stop relying on chat history to keep track of where you are in a workflow. It's just so inefficient and super prone to errors. Instead, use a proper state machine. There are great tools out there like LangGraph or Temporal that are built for this. When you do it this way, you can pass the LLM only the tiny piece of data it needs for the current step, not the entire history of the universe.
And finally, be smarter than your agent. Come on, you can do it. If you know that your workflow is always going to need a customer's ID from a database, don't just give the LLM a generic search tool and then wait around hoping it figures it out. Just write a simple script to grab that ID before you even call the LLM, and then inject it right into the prompt. Boom! You've just saved an entire expensive and time-consuming reasoning loop.
Okay, so we've been getting a little technical here, but why does all of this actually matter? Because if you're building a SaaS product, this architectural choice has absolutely massive business implications. This isn't just about building something clever. It's about building a product that is profitable and maybe even more important, reliable.
First, and most obviously, you're going to slash your token costs by 50 to 90%. I mean, let that sink in. By getting rid of all those unnecessary reasoning tokens and that insane context window bloat, you are directly protecting your unit economics. You're making your business viable when it's time to scale.
Second, check out this number, 0. You reduce the risk of your agent getting stuck in an infinite loop to 0. We've all seen it. When the LLM is in charge, it can get confused and just call the same tool over and over and over. But when your code is in charge of the loop, you get controlled, predictable execution. Your system can't just wander off a cliff.
And that brings us to 100% audibility. This is huge. When a customer asks, hey, why did the system do that? You do not want your answer to be, I don't know, the prompt is kind of a black box. With a hybrid system, you can point to a specific line of code, a specific if statement that made the call. That's the kind of accountability that real businesses pay for. And all of this leads to a really crucial mindset shift. For your business customers, especially in big industries like finance or legal tech, determinism is a feature, not a bug. They are not paying for some creative, autonomous agent that might just decide to skip a crucial compliance check on a whim. They are paying for a reliable, predictable workflow that just happens to use AI to handle the messy, unstructured parts.
So I'll leave you with this one question. Take a really hard look at the system that you're building right now. Is it a reliable tool that's built for the realities of production, with predictable costs and predictable behavior? Or is it just an expensive demo, one that's never going to truly scale? The choice, really, is in your architecture.